Okay, so 1.4 arithmetic sequences and series. This will be the last thing before your test. Last year when I did topic 1, it just got so much and so big, and the test was like, there was like one little question on everything, so if you messed up, you messed up it all, okay? So this year I decided to break it up, and we're doing 1-1 through 1-4. Your test is Friday, okay? So everything is due Friday, right? Before your test, not after. Everything's due Friday. We're going to walk away and be clear and free of it. So the last thing we're going to do is arithmetic sequences and series. So there's lots of definitions today. You need to probably know what they are. Some of them you need to write down. Some of them you don't. So that means I have to think. Okay, if I already know what that is, do I need to write it down? No. What?
Go back, please.
Arithmetic sequences and series. Arithmetic's right here. Sequence and series. Okay? 1.4. So a list of numbers formed by a common rule is a sequence, guys. 2, 4, 6, 2, 4, 6, 8. Okay, what does the ... mean behind it? Keeps going forever. What is my rule? Algebraic rule? Plus 2 is what I'm doing, and then we'd have to figure out an equation to get any of those, correct? This term right here is called A sub 1. It's the first term. So I plugged in a 1 and got out 2. And guess what 4 is called? A sub 2. And 6 is A sub 3. And I'm saying sub, guys, because it's subscript. Okay, so if I said that, I plugged in 1, got out 2, plugged in 2, got out 4, plugged in 3, got out 6, plugged in 4, got out 8. What's my rule? Let's think of an algebraic rule.
Plus 2. X plus 2.
X plus 2? So X plus 2. Now, second, I plugged in 1 and got out 2. Would that work? No. I get 3, wouldn't I? Okay, that doesn't work. Think of another one. Plugged in 1, got 2. Plugged in 2, got 4. Plugged in 3, got 6. Plugged in 4, got 8.
8 times
2.
8 times.
8 times 2, or 2x, or 2n, or 2 something, right? If I plug in 1, do I get 2?
Mm-hmm.
Plug in 2, do I get 4? Plug in 3, do I get 6? Plug in 4, do I get 8? Yes. Okay. That is a list of numbers that has a common rule, and that is a sequence. I'm sorry, a sequence, yes. An arithmetic series, and that should be sequence. That should be sequence, not series, guys. Okay? An arithmetic sequence is a sequence with a common difference between consecutive terms. So that means it can be a positive difference or a negative difference. Correct? Yes? So, is there a common difference between those terms? Am I adding 2 every time? Mm-hmm. Yeah. So D would be 2. So, is it arithmetic? Is this sequence I wrote right here arithmetic? Yeah. Yes. Okay, and then is this the rule to get it? 2x. Yes? So the next example says, is the sequence arithmetic? 3, 8, 13, 18, 23. So I got to figure out, what's the difference between 3 and 8? 5. And what's the 8 and 13? 5, 5, and 5. Aren't you taking 23 minus 18? 18 minus 13? 13 minus 8? 8 minus 3. You take the second minus the first.
I have my keys in here.
I don't think so. Nobody said they found some keys. When we find the difference for the difference formula, do we take the second minus the first? Yes? Those are all things we commonly do to find a common difference. Now, if these were negative numbers, the common difference wouldn't be positive 5. It would be what? Negative 5. And is it okay to have a positive or a negative? Yes. So D equals 5. What's the next term in the sequence? So it says, what is the common difference? So we have D equals 5, yes. And how are we going to find the next term?
28.
28. How did you do that? Add 5. So A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, A sub 6 is 23. It is, 23 plus 5, which is 28. What is A sub 7?
It'd be 28 plus 5.
It'd be 28 plus 5, which is 33. Okay, what we're doing right now is called a recursive definition. Recursive sounds like reoccur, yes? Mm-hmm. Is that what we're having to do? We had to have the 5th term to get the 6th term. Did we have to have the 6th to get the 7th? Yeah, what if I wanted like the 110th term?
You have to keep on going.
Yeah, that's going to take a long time, right? So we're going to start off with recursive definitions, and then we're going to get explicit. What do you think an explicit definition does? I just, it does not do that. It allows me not to go through 128 if I want the 129th term. It allows me to plug in 129 and get the term I want. Is that more efficient? Yeah. Okay, so next thing we're going to do is how could we write this formula for the next term? So this is the term we just had, right? We found already the difference was what? 5. Okay, so we know D is 5, yes? Now that first one we came out with 2x, wasn't it? That's what we came out with? So this one, A sub 1, when we plugged in 1, we got 3. Plugged in 2, we got what? 8. Plugged in 3, got 13. Plugged in 4, got 18. Plugged in 5. Okay. So, well, let's do it the way we did. If we started with, we do A sub n, because that means the number we want, right? Yes?
Mm-hmm.
Okay. So we started with 3, right? 3 when n equals 1. Yes? When I plugged in, like if n was 1, I get 3. Is that what I have? N is 1, get 3. Good? How do I get to the next one?
8
Plus 5. Yes? Now, but I need the term before it. So if I want if I want 2, I had to use 1, yes? If I want 3, I had to use what? 2. If I had 4, I had to use 3. If I had 5, I had to use 4. If I wanted 6, I had to use 5. So I want the one before it. So I'm going to write this here just so we can see it. So if I wanted 5, I would have to use A sub 4 plus 5. Yes? Mm-hmm. Now this was an n, and this was an n. So n minus 1. If this is 5, what's 5 minus 1? 4. Okay, so this tells me that I would have to have the one before it to get to the next one, wouldn't I? Yeah. Okay. Again, this is called a what definition? Recursive. Okay. A recursive definition, each term is defined by the operation on a previous term.
I can't even read half of that stuff.
What can't you read?
That thing.
What?
More specific, probably.
So you're saying D minus 5, the thing underneath it.
That's A sub n.
That does not look like an A, it looks like a Q.
Carly, she's literally said A like 30 times. It's up there.
I was doing something.
4, 5, 6.
Hey, just stop. Stop. Okay, so what we've written is a recursive definition. Is that going to be efficient for us? No. Recursive definitions have to have two things. They have to have a starting point. Do we have a starting point?
Yeah.
We have 3, yes. And does it have a rule to get to the next one? Yes. Okay. That is a recursive definition.
Can I write that?
You said a starting point and what else?
And a definition. So what we have, and they call them an initial condition, and then a definition or a rule.
Okay.
Definition, rule, equation all means the same thing. Now, has anybody ever heard of the Fibonacci sequence?
Yes.
Yes, that is actually the most famous recursive definition. And actually it is n sub 1 equals 1, n sub 2 equals 1, and a sub n equals a sub n minus 2 plus a sub n minus 1. Okay, so that gave me not one initial condition, but what? 2. And all this says is take the first one and add the second one, yes? So my sequence would be 1, comma 1. And what's 1 plus 1? 2. Now 1 plus 2 is?
3,
2 plus 3 is?
5,
3 plus 5 is? What's the next one?
21, 34,
Okay, do you guys get it?
55.
And it goes forever. What is cool about the Fibonacci sequence is I keep talking about this explicit definition that I said would be more efficient, yes? It has been tried to get an explicit definition. There are mathematicians that are still working on it. You guys know how old Fibonacci is? Like
like 18.
1800s.
Now the 15, it would be.
No, he was older than that.
That would be the 1500s in Italy.
Right, it was the Renaissance age. Okay, so Fibonacci sequence has been around a long time, yes? Okay, there are still mathematicians that are trying to write an explicit definition. So if I wanted the 100th term of the Fibonacci sequence, I could plug in 100. So they may write one that they can get to like the 10th or the 100th, but if they keep trying it, guess what it happens? It doesn't work. It fails. And if I say it's a rule, does it have to work once? No, it has to work every time, right? We talked about that last year in geometry with counterexamples, didn't we? And so they can't do it. There are sequences that you can only write recursively, and they're a pain because when we want a lot of them, it takes a long time to get there, right? What is really cool, though, about the Fibonacci sequence is if you pick up a flower, like if you pick a flower before any petals fall off of it, and you count the number of petals, that number will occur in the Fibonacci sequence. Pine cones, have you ever in science talked about pine cones? Actually, they spiral around. The number of seeds on a pine cone are in the Fibonacci sequence. Bees actually reproduce in the Fibonacci sequence. The pattern that they do forms the Fibonacci sequence. Don't know why. They find it in nature everywhere, and they can't figure out why, but it shows up all the time.
It's because the government programming.
Yeah,
Yeah.
because we're all a machine.
Well, on a simulation,
Okay, so next one says, so the following sequence, is it arithmetic? If so, what is the recursive definition? And what is the next term in the sequence? So 25, 20, 15, 10. Minus 5. That was pretty easy, right? So D equals negative 5. Yes? Okay, so we have to make a recursive definition. So A sub n equals, and our nice curly brackets, right? And when, or A sub 1 equals what? I'm going to write it a little bit differently than I just did because I don't like how writing it the other way. So A sub 1 is what? What's the very first term?
25.
25. Okay?
Why do you put an N there?
Because that's the term I want. This is it. The n for this, Carly, look up here. The n for 25 is 1. The n for 20 is 2. The n for 15 is 3. The n for 10 is 4. Because that's the number of term in the sequence.
So how do you get N?
That's what you have, like if I want
It's like
n
a
sub
variable.
10.
So I
You know how
could
we
use
It's a variable.
So I could use like
6.
X.
Well, yeah, but we use n because it's the number of term in the sequence.
But there's -5 in the sequence.
No, there's
No, that's the difference. That's the difference. Okay. So now we need to write an equation. Okay? So we're going to take a sub n minus 1. That's the starting point. Yes, the first one. And what am I going to do with that to get to the second one?
Minus 5.
Minus 5. Yes? So if I have a sub 1 is 5, can I get, or 25, can I get every term after that?
Yes.
Tyson? But I have to have a starting point. Could I just give this right here? No. Okay, then it lastly says what's the next term? So this is 1, 2, 3, 4. Which one are we trying to find? 5. So a sub 5 equals a sub, now Carly, this might help. 5 minus 1 minus 5. What is 5 minus 1, Carly?
5 minus 1 is 4.
4. So a sub 4 minus 5. What is a sub 4, Carly?
10.
Minus 5, which is what?
5.
Why are you
I
making it so difficult?
Yeah, I couldn't.
I didn't think she was getting what was going on. That's why I was showing her.
I got
Okay.
that.
Okay. So the big thing that throws people off is this, they see this a sub n minus 1 right here. Okay?
Yeah, what is that?
When you see, because it says use the previous term. Anytime you see this n minus 1, I could also write it in terms of plus 1. You could put the plus 1 out here. It's just different. You could put the plus 1 out here where the a sub n is. You could put a sub n plus 1, and this would just be a sub n minus 5. And you put a sub n is 25. 1, 25. Okay, so anytime you see this n minus 1, you know it's recursive. Okay, that means you have to use the previous term, yes? And what does this tell me I'm doing to the previous term? Minusing 5. That's all I need to know. Where do I start? 25, and what am I doing? Subtracting 25 or 5.
You only have one more example.
Wait a minute, why did you go with A 5 minus 1 minus 5 and then A 4 minus 5?
Because what is 5 minus 1?
Oh, that's the big 5. Never mind.
Yeah, these
I
are
thought
little.
you were the-
No, those are little.
4 minus 5
Okay.
is 9.
No, she. Okay, 2, 4, 7, 12, 13.
Add
2, 3, 5, 1. Is it arithmetic?
No.
So it's that easy.
Yep.
But what if you
Can I
go
write that
2,
in real
3,
fast?
5, 1 again?
No, it has to be the same. It has to be a common difference. It has to be
Now,
the
if it
same
was
every
2,
time.
3, 5, 7, or
No, it has to be exactly the same every time. So it'd have to be 2, 2, 2, 2, 3, 3, 3, 3.
So, like, you could have got that from the first hit.
Aren't
You
there
did
some,
not
aren't there
have the
some
last-
sequences though
there
that
was
do
the
go
last
like?
two.
They're not arithmetic. They're not. They are sequences, but they're not arithmetic sequences. Okay? There's arithmetic, geometric, and then neither. And then neither combine different concepts together. Arithmetic is add or subtract. What do you think geometric is? Multiply or divide. And we just usually say multiply because then we just multiply by fraction for division. So you can either add or subtract or multiply, but if you combine the two, they say neither. And we're only going to be focusing on arithmetic for now. Okay, so explicit. Now, recursive was you had to have a previous term, yes? Explicit allows you to find any term in the sequence without knowing the previous term. Wouldn't that be amazing? Yes. And how we can do that is right here. Hopefully it highlights it and not yellows it out. Is right here. That should be a sub n on the outside. Should be big A, little n. A sub n equals a sub 1 plus d times n minus 1. Now, a sub 1 is which term?
First term.
The first term. What does D stand for?
Difference.
Common difference. N is a variable, yes? So are we going to fill anything in for it? No. This is how we write a rule. This is the rule definition. Right here is the rule for writing arithmetic sequences. Got it?
Yeah.
So in order to do this, I have to have what two things? A sub 1 and the difference. Make sense? So we wrote a recursive definition. I don't even know why this one's here because it wouldn't work. I don't think I wrote down the wrong thing. We wrote an explicit definition for 25, 20, 15, and 10, yes? Yes? And then if I ask you for a sub 263, you guys would be like, nope. Correct? So I want to write an explicit definition. So the explicit definition, I have to have a sub 1 and I have to have d. So what is a sub 1? 25. What is d?
-5.
Minus 5. So all I do is plug them into the rule and simplify. So a sub n equals a sub 1, which is 25 plus, I'm going to put the parentheses first, n minus 1 times negative 5. Just because it's negative.
Why wouldn't you do 25 minus 5?
Well, because this is multiplication right here, yes? Yes. And so what do I have? Rule of order of operations tells me I have to do what? Multiply first, so I have to distribute. If I put that minus 5, would you be tempted not to distribute? You could write it 25 minus 5 and minus 1 if you want. But it is not 25 minus 5, is it? No. Angela. Okay? So I have to distribute the negative 5, don't I? So here and here. So I get 25, what? Minus 5n. No, minus 5n.
5n plus 5.
That's what I said.
I thought you said I thought you said plus.
I said -5n and I was going for plus 5.
Oh, okay. And then I simplify. They're like terms?
Yes.
25 and 5 is what? 30 minus 5n. So right here, does it work? This is n sub 1, 2, 3, and 4, yes? So if I plug in 1, what do I get? Plug in 1 into this equation, what do you get?
25.
You get 25. If you plug in 2, what do you get?
20.
3,
15,
4.
10.
Okay. Now, I told you I wanted a sub 230, what? We'll do 231.
Okay,
So what do? Plug in what?
-5, or what you plug in 231.
So 3 minus 5 times 231. Okay, so 30. Yes. Okay. So
Is this so
5,
simple?
5.
Putting a random number.
I'm showing you how we can use this.
It would be -1,125.
Okay. So was that a lot easier than going through 230 problems, subtracting 5, and then doing it one more time? Yes. Okay. So an explicit definition is much more efficient, and we should try to write things explicitly. Now, your book is going to ask you for explicit and recursive. Okay? It says, for the recursive definition here, what is the explicit definition? Okay? So they give me a recursive definition. Right here, see it? Okay, it says my first number is 45, and what do I do to get to the next one? Minus 2. Okay? Well, equals 1 when it's a sub 1. Like I wrote it, a sub 1 equaled. It's the same thing. When the number, there's just a different way to write it. Okay, so we need to write for the explicit, we have a sub n equals a sub 1 plus n minus 1 d. And I write my d at the back because in pre-calc, that's how they write it, and I've written that way forever. Does it matter if the d is in the back or in the front of that quantity? No, you distribute it the same either way. So what two things do I have to write this definition? I need a sub 1 and what? D? So if n is 1, the answer is 45. So a sub 1 is 45, right? And what is d?
-2.
-2. Okay. Now, it might not always be -2. What if I put like a 3 up here? Would that change it a little bit?
Yeah.
Yeah, you'd have to plug in 2 and then figure it out. Okay, so now I just plug it in here, correct? So a sub n equals, a sub 1 is 45 plus n minus 1. And what's your common difference?
-2.
-2. Distribute your -2 and combine like terms. So 45 minus 2n plus 2. So a sub n equals 47 minus 2n. Okay?
Wouldn't it be 43?
Yeah.
No.
No, 'cause
You have a negative and a negative as a positive, so you have 45 plus 2. Because we're subtracting, so our numbers are going to get smaller. Okay, so now I got to go backwards. I got to go from explicit to recursive, so from here to here. Okay? So I've got to write a sub n equals. We can write it this way, or do you guys just want to put a sub 1 equals? I like the a sub 1 equals, don't you? Okay, so how am I going to find a sub 1? I'm going to plug in what? 1. So you plug in 1 into here. Well, what's 1 minus 1?
0,
0. What's 0 times 7?
0,
So what's a sub 1?
0.
What's 0 plus 1?
Oh,
1. How did we get that again? We just
Plug the one.
you plug the 1 into the n.
you plug the n because this is a sub 1. What did the n turn into?
Wouldn't it be a-n?
Okay, 1 plus 7 times 1 minus 1. What is 1 minus 1? 0. 1 plus 7 times 0. What is 7 times 0? What is 7 times 0? 0. 1 plus 0 is 1. Order of operations. Okay? So now what am I doing to each thing? What's my common difference?
7.
7. I'm adding 7 each time, yes? Because that's the difference here, isn't it? So it'd be a sub n minus 1 plus 7. And if we wrote it this way, we don't have to do this inequality thing. That's why I like it.
Can you do that? Is that always going to be n minus 1?
Mm-hmm. Yes, because you're doing the previous term. Now the Fibonacci had two initial conditions. You won't ever have anything like that. Not in here. Maybe pre-calc, but not in here. Because we're going to do the same thing again next year. A little bit more in depth. Yes?
So you put the curly brackets on one side, why don't we put curly brackets on the other side?
Because curly brackets on one side shows a set and has two conditions in that set. There's nothing that uses curly brackets on both sides.
Okay.
It's just formatting.
Okay.
Okay, now I'm going to tell you the process of going from explicit to recursive very rarely happens. We go from recursive to explicit a lot. I don't know why this book likes you to go the other direction. I probably wouldn't ask you to do that on a test. Okay?
Yeah.
Next thing we're going to do. This you don't have to write down. I want to ask you something. One day, long time ago, probably even before Fibonacci, I think. I need to look at my timeline. A little kid named Galson was sitting there with his tutor and annoying his tutor. And his tutor said, go away. Go add up the integers from 1 to 100. Go add them up. And he was like, maybe 7 or 8. Like, get out of here. So his tutor expected him to say 1 plus 4. 1 plus 2 is, plus 3 is 6, plus 4 is 10. Okay, so you expected him to be out of his hair for a long time, yes? Yes. Gaussian came back in about 5 minutes and had an answer. Okay?
Oh, I've done that.
And he had an answer. And his tutor was like, you're so full crap, you don't have it, get away, you're not done. Go add it up. Okay? And the answer, I need to do a little, I need to do a little math over here.
I wouldn't even be
She's
able to
gonna make
figure
us
it
do
out
it.
myself.
It's not that hard.
No, it's not.
Yeah, it is.
No.
Yes.
No, it's really not.
It's really
It's,
Yeah, it's really hard.
The answer is,
plus 3 is 6, plus 4 is, you just like you.
I just did it.
Yeah, you add 1 plus 2.
Okay.
50.
No. No, he's even making it harder.
I'll forget the
The answer is 5,050. Okay? So what Gaussian did is he sat there going 1, 2, 3, 4, and he got 4. He's like, this is stupid. And then he started going 100, 99, 98, 97, because he was going to write them all out. And he's like, this is stupid, I'm done. And he looks at it and he goes, well, wait a second. What's 1 plus 100?
101.
101. What's 2 plus 99?
101.
What's 3 plus 98?
101.
What's 4 plus 97?
101.
101. It's 101. How many pairs of 101 do you have between 1 and 100? 50.
Smart man.
Okay. He was like 7.
Oh, no.
Okay.
I can't even do it.
This works with every single arithmetic sequence. Every single one. Now, I can't do it with infinite. Why not? You don't know what the end is, do you? And what we did is we took the first plus the last, didn't we? Okay? And then we multiplied it. So we took a sub 1 plus a sub n first plus the last. Yes? And we multiplied it by n over 2. Because 1 to 100, what's your n? 100? Yes? There's 100 things between 1 and 100. And he divided it by 2 because he had 50 pairs of numbers. Now, it's not always going to be even, okay? But when we multiply by 2, we always end up with a decimal 0.5, don't we?
Yes.
Yeah, so it shouldn't be too hard. So what we have is a formula that works for finite. What does finite mean? What does finite mean? What's infinite mean? It goes forever. So what's finite mean?
It stops.
Not. It stops at some point. Okay, we just talked about we can't do an infinite, can we? Can I take an infinite sequence and cut off the first 200? Yeah.
Yeah.
Can I cut off the first 800? Yeah. But can I get to infinity?
No.
No.
It's undefined.
It's undefined. So the sum of a finite arithmetic sequence is S sub n, and n still stands for the number of terms you're adding. Okay, n stood for the number of term it was, yes. We're still, S sub 100 means I'm adding how many terms? 100 of n, same n. A sub 1 is which term? The first one. And a sub n is the last term. And we divide it by 2 because we're making pairs. Now, when I wrote it, I wrote n over 2 times a sub 1 plus a sub n. Is that the same formula?
Yes.
Yes. I like it like this in the blue. My brain likes that better.
I don't like it as a fraction.
Okay? Yes, but I would rather have some one thing divided by 2 than the whole thing divided by 2 in my brain. Sorry. It's never going to go away.
Yes, it will.
Okay.
When you're out of school.
So, guys got it?
Yes.
Got it down?
Yes.
Okay, so it says find the sum. Well, first of all, it better be arithmetic. So 2 to 6 is what?
4.
6 to 10 is?
4.
10 to 14?
4.
Okay, so is it arithmetic?
4.
Okay, so I need to know how many terms there are. So what's n?
6.
6. What's a sub 1?
2.
And what's a sub n?
22.
22. So I just plug it in the formula. So S sub what?
Where did you get 6?
22.
1, 2, 3, 4, 5, 6. There's 6 terms.
Oh,
Okay.
There's 6 terms. Okay? So it's S sub n, and what's n?
6.
6. So S sub 6 equals, I'm going to use mine, okay? So n again, what's n?
6.
6 divided by 2. Always. Why is it 2? Because we're making what? Pairs? Yes, there's 2 things in a pair. And a sub 1 is
2.
plus
22.
22. And if 22 is negative, it'd be minus, right? Okay, what's half of 6?
3.
And 2 plus 22 is?
24.
And 2. You guys do the math and I'll do the math. We better get the same thing, right?
72.
I get 72. What about you guys?
Yep.
Now, these 6 numbers, could I add up fairly quickly?
yeah.
Yeah. But what if those 6 numbers were like minus and, you had to switch somewhere in the middle between positive and negative? And what if I didn't have 6 but I had 36? Would that make it this very efficient?
Yeah.
Yes. Now, could I check my work? 2 plus 6 is 8, plus 10 is 18, plus 14 is what, 32?
Yep.
Plus 18 is 40, 50, plus 22 is 72. Now, that even took me longer to do that way than it did even using the formula, didn't it? Okay, and there was just 6 numbers.
I like that way.
You like just adding it up?
No, just no.
Oh, okay. But what do we have to make sure is true about this before I can use this?
It's arithmetic.
It's arithmetic, okay? If it is not arithmetic, this does not work. Got me?
Yes.
Okay. Okay. Nope, that's what I was just going to ask. Again, it only works when it's what?
Arithmetic.
Arithmetic, hence the name, correct?
What does the S mean?
Is this the last
Some.
one we're doing?
Some. I think so. I mean, we got some examples, but I think this is it.
You think?
No, we got to do sigma notation.
Are you kidding me?
It's easy. It's just notation. I said sigma notation.
I don't know what notation means.
How you note
You know
something.
what scientific notation is?
Okay, it's just a different way to write stuff. Okay, it says find the sum of the arithmetic sequence. There's 2 of them. Okay, there's an example. My equation is S sub n. Gosh darn it. S sub n equals n over 2 times a sub 1 plus a sub n. Yes? So the first one is S sub what?
12.
12, because it says what?
12 times
12 terms. Equals,
3.
3. Well, a sub 1.
no, n is,
Oh, 6
And
over 2.
equals
no, 12
N 2.
over 2.
Oh.
You did the answer, Jaden. You divided it by 2, and then we're going to divide it again.
Plus 25.
Okay, a sub n is, or a sub 1 is
3.
3 plus a sub n.
25. So it's going to be 6 times 28, which is going to be what?
I get 168.
Probably.
You guys check me out. Check it out.
I don't feel like doing that in my head.
It's not that hard.
I'm
I
confused.
just don't want to.
What are you confused about, Kyson?
8, so it's going to be 48.
Kyson, ask, please.
4, 12.
It's 168.
Yeah.
Okay, Kyson, where are you confused at?
Never mind. Oh. He's still lost. Can you tell in his face?
Okay, do you understand the formula here?
Oh, okay. Somewhat now.
Okay, so n is the number of terms we're adding. We're adding 12 terms.
I got it.
Okay, the first one is 3, the last one is 25, and so I just plug it in. Okay, so this one, it's S sub what? 7? How did we get 7?
7 terms.
There's 7 terms.
Wait, miss.
Okay. So it's 7 over 2. Yes?
Wait, why is
Yes.
it 2?
Because it's always 2, because you're making pairs.
Okay, Miss Mick, if we had negatives.
That if it was negative, you would just subtract. Like if this number was negative 41, it would be 5 minus 41. Don't worry about it. Okay. So then what's a sub 1?
5.
5
Junior high volleyball.
plus 41.
And football. Buttons in the office.
So 7 over 2.
3.5.
Nope.
Oh,
You're making it hard.
miss.
Equals 46, yes?
Yes.
Okay, that's 46 over 1, isn't it?
Yeah.
Does 2 go into 46?
Oh, yeah.
23 times.
So it'd be 7. Oh.
No, it'd be 7 times 23.
So would I get the same answer?
Yeah, you would, but it'd be
46 times
harder.
3.5?
Yeah, it'd be
I
harder.
would rather do that times 3.5.
Well, then you do it times 3.5 and we better get the same answer, right? I get 161.
Probably. Yeah.
Okay,
7 times
so
23 is-
does it have to be an even number? No. At most, you're going to have a 0.5, correct?
Yeah.
Okay. Now, the last thing we have is summation notation. This right here,
What?
shh, guys, when it does that, don't overreact.
No, I'm talking about the symbol.
Okay, sigma. Let me talk. That is a sigma. Ever heard fraternities and sororities with sigma whatever? Okay, sigma is a sum. It's a capital S in Greek. Put your chair down. Okay, it is a capital S in Greek. It's really easy to write. You go dunk, 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 dunk. It's an M on the side. It's not difficult.
It's a fancy E.
No, it's an S. It's an S.
It's a fancy
Why don't they just
Okay.
do like this?
So just stop. This is sigma notation. Okay, we don't have much time, so we just need to focus. Got it? Okay, sigma notation, this A sub right here, this A sub 1, it's just your definition, your rule, whatever you come up with. Like we did A sub 1 plus 6. That's what would go there. Okay? I is your index. I from 1 to whatever n is. 1 is your lower limit, n is your, guess what? Upper limit.
Wait, what is
It is usually, it is usually written like this. See that? Okay. With formatting on a computer, it puts it next to it and not below and above. Got me? In your textbook, it will be written below and above. Sigma means to add sum, what we just got done doing, yes?
Yeah.
What?
So would the A sub 1 then be like,
That would be your look at the example.
Yeah.
I'm gonna let me talk. I'm getting there. You're interrupting me. You're interrupting my instruction. Let me talk, please. Okay, so transfer this down here. Got it. Okay, I have the sum. I don't even say sigma. I say sum because it means what? Sum. From I equals 1 to 9 of 2I minus 6. So that means I plug in 1, then 2, then 3, then 4, then what? 5, all the way to what? 9. So into this rule. So if I plugged in 1, I'd have 2 minus 6 is negative 4.
Yeah.
Yes? And then if I plugged in 2, I'd have 4 minus 6 is negative 2. If I plugged in 3, I would have 0. Okay, so your assignment is page 37, 5 through 11. Do as much as you can. When you get to the sigma notation stuff, we'll finish talking about it when? Tomorrow. But do as much as you can because most of it is not on sigma notation. Understand?
Yes.
It's the do you know, and that's it.